Okay, by now we're all very confident users of Resolve. We've been through a load of lectures and practical projects to get to this point. So what's next? Well, we've been learning to use the toolset within Resolve, but we've been doing so in the simplest environment. We haven't been carrying out any color management at all. Now, what we've been doing so far is fine for web video, and I'm guessing that's at least 80% of what you're all working on. But we must talk about broadcast and cinema as well. The thing is, web, broadcast and cinema, all referred to as delivery destinations, all have different combinations of color spaces, gamma coefficients and white points. So, if we're going to deliver a project to broadcast or cinema, we have to make sure that we have a few boxes checked first. First is our monitoring solution. Now, we've probably been using our built-in laptop monitors or standard GUI, that's graphical user interface monitors, until now. If you want to deliver for broadcast or cinema, and Netflix kind of counts as both of those, then you need to know for certain that what you're delivering is going to look right in its delivery destination. Now here's the thing. Your standard monitor is probably not set up to mimic either broadcast or cinema. It will likely be fine for web, but that's another matter. For broadcast and cinema work, we need to use what we call an external reference monitor, a high-end, super accurate monitor that can display a broader array of colors than a typical GUI solution. Reference monitors are expensive, running from the equivalent of around $700 to tens of thousands of American dollars. But to deliver to broadcast and cinema, we need one, as standard GUI monitors are not good enough. Now, we'll go into these in more depth in the next module, but for now, if you're planning to work on content for television or cinema, you need to be thinking about this. I'm mentioning this now to avoid confusion. It's not enough to set your color management up and then just grade as you would for a web video. Next are the appropriate color management settings. In this module, we're going to learn how to set our grading environments up for delivery to cinema and broadcast in preparation for the final online edit, which may take place either in Resolve or in another program such as Avid. Using the color management settings, we will tell Resolve what color space and gamma was used to capture our footage, what color space we want to work in on the timeline, and what color space we need to deliver at the end. Now, it is super important that we get all of this sorted right at the start of any grading project. We cannot go ahead and change this afterwards because it will interfere with all of the grading work we have carried out so far. We get this set up first, and then we continue with the rest of the grade. We are going to break this down into steps and go through a few examples of setting projects up for various delivery destinations in the next few lectures. So click on through once you're ready. Right, this is just a quick revisional video for what comes next, essentially. The next lecture goes into quite a bit of detail about the color management process, but in version 17, there's an update which makes this a lot easier for certain kinds of... So we're just going to look at those basic controls in this one, and then we'll go straight on to the original lecture, which goes through all of the nuts and bolts required to do it all manually. So in the lower right of the screen, we're going to click on the gear. This opens up our main menu, and from this we're going to hit the color management option. And basically what we have now is a load of presets that we can use. So if I go from DaVinci YRGB, this is the standard color science, to color managed, what I can do is I can choose all kinds of preset color management settings that can help us deliver all kinds of different delivery destinations. So basically I have my Resolve color management preset here, and I can choose SDR, Rec 709, SDR, P3 broadcast, yada yada yada. The big one here is SDR, Rec 709. And this is the default. This is basically good for all web work and a lot of broadcast as well, provided you're looking at a monitor with 2.4 gamma. Down below we have broadcast and cinema, SDR P3 cinema. This is if you are preparing something for the theatre. If you're going to do a DCP export later on, this is what you would start working in. You need to use a monitor capable of P3 and 2.6 in there. And all of these are pretty self-explanatory. The only other two to be aware of are HDR P3 and HDR Rec 2020. These are HDR delivery presets, and what you need depends on the person you're delivering to. They will be able to tell you whether they take P3 for broadcast or Rec 2020 for something else, probably broadcast or possibly streaming as well. And then at the bottom we have custom, and custom's going to open up all of these options that we're going to go through in detail in the next lecture, so we'll do that then. Lastly, we have our output color space. Now the output is quite important. Basically, we have our Resolve color management up here, and then we have the output. Our output usually should match the delivery destination. Now, we talk about the difference between scene referred and display referred, and we go through that in a lot of detail in the very next lecture, so I won't repeat myself here. But basically, we don't typically need to change this if we're just working on a monitor. But if we have a different scene referred workflow, we will need to change this output color space. But again, we do that all in the next lecture, so no worries right now. Then we just hit save, and all of our color management settings are applied to our project. So that's really it for this one. It's short and sweet. It's just basically showing you that the preset drop-down menu is there now, and that you have to hit the custom option in order to see all of the options you're going to see in the next lecture. So with that being said, go on and click through once you're ready. So we've got a broad overview of the concept of color management. Now we need to look at how we actually set everything up and make sure we're aiming in the right direction from the off. Now, the default color management settings of Resolve don't actually make any changes. We bring our footage in whatever color space and gamma it has been captured with, and then we grade in a Rec. 709 timeline. Resolve, by default, believes that everything that is brought into a project has been captured with Rec. 709 color space and a gamma of 2.4 unless we tell it otherwise. That means that it's not actually changing anything, as it already believes everything is correctly set up. Now this may seem like it poses us with a problem. The gamma for web video is 2.2, but Resolve is not set up for 2x2 by default. So have we been grading in the wrong environment all this time? It may sound like it, but no, we're fine. I'll explain why. This comes down to something that we call display referred color management. Originally, we didn't used to have these settings. All we had was our external display. No matter what, we are entirely dependent on the calibration and capacity of our monitors to ensure that our projects hit all the right notes for final delivery. This means that if we graded on a 2.4 gamma monitor, we would deliver 2.4 gamma content, and the same would be true for 2.2 or 2.6. By default, if we do not use any color management in Resolve, this is what we are doing. Our output depends entirely on our monitors here, so in all likelihood, we are all working on 2.2 gamma monitors since we are working on either workstations or laptops. That means we are working on and delivering 2.2 gamma content which is actually suitable for web video. Now, this may sound complicated, but the practical takeaway is as follows. If we do not use any color management settings, the gamma of our content is dictated by the monitors we are using. So for web video, we don't need to change any of these settings. You can just bring your footage in and grade it like we've been doing this whole time. Now, a lot of the time this can actually be okay. We're making sure that everything looks good in Rec. 709 and 2.2 gamma for web. But we can shortcut the first steps of the grade using color management tools, as well as make sure we are working in a color space intended for broadcast cinema or web depending on our choice of delivery destination. Let's go into changing the color management settings. So first, we need to bring in some source material. I'm back here on the Talking Head project. I've disabled the grades for this clip so we can see the effect that our color management is going to have on everything. Now, this is a ProRes 4x4 project shot in Log C on an Arri Alexa, and you can see it gives us the recognizable flat profile. We want to set ourselves up to have a better starting point, but we don't want to go through and grade everything by hand this time. We want to have the machine give us the best place to start with. So, this brings us to what we call scene referred color management. This is when we have given Resolve some information about how clips should be decoded and represented in a given color space. So before, we were the only authority on how a clip should look, but now we're going to tell Resolve what the clip's color space is, and it's going to take a part in this as well. If I tell Resolve that all my material is shot in Log C, and that I want to see it all translated to Rec. 709 at 2.2 gamma, then I can do that, and Resolve will attempt to make the first step of the grade for me. In order to do this, I need to click the gear in the bottom right, and I need to choose the color management heading. Now I can see a load of grayed out sliders. I need to click on the color science drop down here, and I need to choose DaVinci YRGB Color Managed, and this now allows me to make all kinds of changes to my color management settings. Before we go any further, just one thing. You don't need to use these settings. If you find them confusing or you prefer to grade from scratch, that is fine. With the default DaVinci YRGB selected, you're working in what we call a display referred environment, and that is when the monitor dictates the final look of the footage you're working on because you are grading to the standard present in that monitor. If you're grading for web and it looks good on your monitor, you're going to be fine, okay? So, back to the point, we now have a bunch of different options: input, timeline, and output color spaces. Let's go over what these mean. First, we have input color space. This is the color space of the material being imported into Resolve. Think of it as a starting point. Resolve will believe that all material in our project was captured with this color space and gamma, and will use that as a starting point for any color transforms that it will make using the color management settings. Now, my stuff was captured in log C, so I just need to go through and find log C in here, ARRI log C. So my input color space is ARRI log C. Your input color space should match what your material was captured with. So if you've shot in log C on an ARRI, your input color space is ARRI log C. If you've shot on Sony RAW, you probably want S log 3. If you've shot on something else like Panasonic Vlog, you're going to want Panasonic Vlog as a starting point. This should match the clips you have here, because Resolve is going to go, right, we're starting at this point, I need to go from ARRI log C to Rec 709. If you have the wrong input color space, if you go from, let's say, red log to Rec 709 on an ARRI clip, it's going to look wrong because it's the wrong transform for the clip. The next setting is timeline color space. This is the color space of the timeline that we're actually working on. This setting will have a pronounced effect on the way our grading controls will feel during the grade. We've been using the standard display-referred monitoring setup until now, so if we change this, things will feel rather different. It can take some getting used to, but you will find that you acclimatize quickly enough. If we have an input and timeline color space that is different, then Resolve will transform the information of our footage to match the timeline color space using the input color space as a starting point. Think of it like this. We start at A, our input color space. Resolve then makes a transform that takes us from A to B, our timeline color space. So far, simple enough. We're going from log C to Rec 709 2.4. Finally, we have our output color space. Resolve will make sure that everything we are seeing in our viewer and on any external monitors will be in the chosen output color space. This means that if the timeline and output color spaces are different, Resolve will transform the footage a second time to make sure that it is displayed in the chosen color space on our external monitors and in our viewer on the color page. Think of this as ending at C. We start at a point of our choosing, the input color space A, then we change from that to the timeline color space of B. Then we change once again and end up at the output color space of C. It's really just a matter of 3 steps. Now, you may think that we want to set up our color management options as follows. We have log C material up here, and then the other two would be Rec 709 Gamma 2.2, and I'll make that change just now, because that's what we're delivering to web. But when we choose this, look at what happens. I'll hit save, and I've got blown out regions in the head and the hair here, and this is not an ideal starting point. What I would have to do is quite a lot of work on top of this starting point to get to a starting point. That obviously defeats the point of doing this. This, therefore, is an incorrect decode. Instead, we have to set up our color management as follows. We want both the input and timeline color spaces to be ARRI log C. And then we want the output to be Rec 709 2.2 Gamma. Now, we have another drop-down that reads timeline to output tone mapping, and so far it's set on none. We need to click that and choose simple. The reason we're doing this is that 10-bit log contains values outside of the typical 8-bit range of Rec 709, hence the blown-out highlights. This option allows us to limit our upper values to the minimum and maximum of the output color space, and it makes these judgments using our timeline color space as a starting point. All we need to do here is choose simple, as we have done just now. And now, when I hit save, see the difference that makes. We now have a pretty good starting point for our grade. And this will produce results more or less identical to simply using ARRI Alexa log C to Rec 709 lookup table. This is Gamma 2.2. I can switch it to Gamma 2.4, and you'll see that it's looking just like a standard log C image with a lookup table attached. Now, one last thing. We don't always have only one model of camera on our shoot. We typically have a range of pickup and B cameras, so we need to know how to deal with multiple input color spaces in Resolve, and this is actually very simple. What I would recommend is to organize all clips into bins based on their source camera. And once we've done that, we can enter a bin and select all of those clips. I'm just going to go into the media pool and I'm going to give a quick demonstration just here. So for argument's sake, I've got clips from a different source camera in here. I'm going to select a number of them and right click. And what you'll notice is we now have an option to define their input color spaces. Doing this will override the project input color space for these clips. We can go ahead and do this for any other clips with a source color space different from our project's input color space. So I can go into input and I can say, actually, it was shot with sgamut3 slog3, and now Resolve goes ahead and turns all of those into then Rec 709. Well, actually, it'll turn everything into log C and then into Rec 709, but then everything else will be correct. So if you have odd clips from different cameras with different color spaces, you have to organize them all together and then manually change their input color space by right-clicking on them, and then they will be factored into your color management pipeline correctly. So this is a good overview of our color management settings. Now, for the most part, this really is optional. This is only mandatory when you're working on either HDR content or you have lots of high-end VFX plates. Let's say you've got a nuke user somewhere in the pipeline and you're getting plates back in either ACES or linear, then you are going to have to use these settings. You're going to have to work scene referred under those circumstances. Personally, if I'm not delivering to cinema, I like to work in the old-fashioned kind of display referred way. Like I said, I still like to work by hand. I like to do as many things as manually as possible because it's just the way I taught myself to grade, and it's just the way that I like working. I'm not a huge fan of lookup tables, as we've established. So, now that we've covered the kind of broad general terms of setting up these color management settings, we're going to go on to some specific delivery setups for cinema and broadcast. So click on through to the next lecture once you are ready. Okay, so we're going to talk about broadcast specification in Europe and North America. Now, these lectures only deal with the technical requirements of the video signal we need to deliver. We are not going to cover any metadata editing in this course, as that honestly varies a great deal between all territories, and I'd end up making about 100 different videos for that, just for that one subject. We're also going to take a look at how to avoid broadcast illegal levels in our projects whilst grading. Now, like we said ages ago in the earlier tech modules, these deliveries come down to a combination of gamut, color space, gamma, and white point. Each delivery destination has its own combination, and provided that we are working in the right grading environment, we can grade comfortably knowing that we'll meet the specified criteria. Now, we already know a good deal about the broadcast specification. We know that for SDR broadcast we deliver YC BCR material in the Rec 709 gamut, and we know that our gamma is 2.4. Delivering in YC BCR is a simple matter of choosing to deliver in a chroma subsampled codec, such as AVC Intra 100, which is a very common specified file delivery format for broadcasts. However, most workflows require an online edit back in another NLE, like Avid or Premiere Pro. This means you can deliver back to most of your clients in either ProRes 42HQ, DNxHR HQX, or ProRes 4x4 or DNxHR 4x4. And if our external monitor is set up to correctly monitor in Rec 709 and 2.4 gamma, then we're set. Now, the majority of monitors are set to have a D65 white point. That is a white point of precisely 6,504 Kelvin. So as long as we have a calibrated monitor, we will be fine when delivering to broadcast. Remember to set any color management up at the start of the project. You're going to want your output color space to be Rec 709 2.4 gamma for broadcast jobs if you're using color management. Remember all of this dialogue here. One quick note on gamma is that there is another notation that can cause confusion. Sometimes you may hear someone referring to a gamma of BT 1886. This is a newer standard for television mastering. It is very, very close to 2.4, and for most purposes, grading in a 2.4 gamma environment is acceptable. Now, there's one last thing to remember. We tend not to deliver full-range material to broadcast unless we are requested to do so. So, in the delivery panel, you're probably going to want your data levels to be set to video manually. Do remember that, and get the specification from your client. That's always extremely important. So, we're going to have to talk about broadcast legality next. We have a relatively small gamut, which is a range of acceptable colours, to work with in broadcast. Combine that with 8 bits of colour depth and chroma subsampling, and we actually don't have a great latitude for colour at all for standard SDR broadcast. This means that we have a relatively small range of colours that will display correctly on standard television sets. We need to make sure that our project looks good on those television sets, so we need to make sure that we deliver colours that will play back correctly on them as well. Here we have a very useful feature in Resolve that allows us to easily spot broadcast illegal colours, and I'm just going to turn my grade back on, and I'm just going to make a quick adjustment to give us some illegal colours to work with. So, identifying broadcast illegal colours is quite simple. Once on the colour page, all we need to do is click on the View option up here, and then click on Display Broadcast Safe Exceptions. This provides us with a false colour overlay. Anything that violates broadcast legality will be overlaid with a very bright and artificial colour, typically yellow, red or blue. Now, most of the time it's only highly saturated colours in the highlights that tend to be broadcast illegal, but we can also get some issues with very crushed shadows as well. We need to go through our project and carry out a safety or trim pass, where we make sure that we cannot see any of these false colour overlays in our shots. In this case, I need to reduce both the brightness and saturation of these qualified reds on this node. So then I'm just going to take that back, and you'll notice bits of the yellow start to disappear. And then when I take the saturation down, and then I've just got to see how far I can push this before it looks a bit off. And there we go. And now I have a completely broadcast safe image. I get no false color overlays. This will pass a QC or quality check for broadcast. Once I've done all of this, I'm ready to move on and then provide my client with a final export that they can use in their online edit. So this was a good overview of getting the technical side of things ready for a delivery to broadcast. Next, we're going to take a look at how we deliver a project for the cinema. Click on through to the next lecture once you're ready. Now it's on to how we get a video stream ready for delivery to cinema. Now, a cinema delivery requires an advanced deliverable known as a DCP, or Digital Cinema Packet. We're not going to go through the entire process of mastering a DCP, but we are going to go through how we prepare a video stream for final DCP mastering. Just like last time, we have a specific combination of color space, gamma and white point, and this time all three are different for cinema. The thing about delivering to cinema is that we need to have our color management pipeline down first. This is particularly important because we can't actually grade in the color space that we need to deliver. Let's talk about this for a second. The color space we use for cinema deliveries is XYZ. Now this can get a little complicated, but most monitors cannot display anything in XYZ, so we have to work in another color space and then transform our work into XYZ right at the end of the grade. We're going to take a look at how to do this. First, we're going to set up our grading environment. Cinema uses a different color space, gamut, gamma and white point compared to broadcast and web, so there's really nothing in common. First, we need to talk about the gamut and the gamma. So let's just take a look. Cinema uses a wider gamut than Rec 709, referred to as P3, and this allows us to send a broader array of colours to the cinema screen compared to broadcast. Now this has very important implications for us in the grade. Our external monitor needs to support 10-bit P3 monitoring. The vast majority of consumer end monitors do not do that at all. Most of them are only 8-bit and Rec 709. Most monitors capable of displaying 10-bit P3 are rather expensive, and I'm afraid that's a cost that's really impossible to dodge. You really do need an accurate and fit-for-purpose monitor to work with if you are delivering to cinema. And the next is the gamma that we need to work with. Gamma 2.6, and this is unique to cinema. It's not used anywhere else. Just like P3, not all monitors support this. We need to work with a screen that can represent these settings accurately, otherwise we cannot produce an accurate grade. And lastly, we have a different white point which is also unique to cinema. It is referred to as DCI. Our monitors must be calibrated to DCI white point, otherwise this is not going to work. So, We have a few ways we can go about making this delivery. Remember, we need to make a transform to XYZ at the end. We can go at this display referred, change nothing, work with what we've got and make sure it looks right in our reference monitor. Or we can use color management if we like in order to shortcut some of the primary grading. We can actually use the same end solution for XYZ transforms in either case. What we need to do is to use an output lookup table at the end of the grade to translate everything into XYZ. So remember the LUTs module way back? Once we've got this color management menu up, we're going to scroll down to the lookup tables option. And we're going to look at the output LUT settings. Under 3D output LUT, what we want to find is P3 DCI to XYZ. And we select that. Now if I hit save, everything's gone all green and weird, but that's actually correct. Remember, we do this right at the end after the grade. We don't do any grading after this step. That's really important. What we now have is all of our graded footage transformed into the XYZ color space. We now need to deliver it to our client so they can proceed with the mastering of the DCP. Now, the DCP process does not take standard footage like a .mov or .mxf file. It takes an image sequence. We are essentially going to render out the entire film in one big clip, but each individual frame is going to be a separate image file. And doing this is quite simple. We go to the delivery panel, and then under format, we can choose either JPEG 2000 or TIFF sequence, which are the two most popular image formats for DCP mastering. Both of these will generate huge files, so make sure you have enough space on your drives. I mean it, if you're doing like a 90-minute 4K feature, you're going to want 3 or 4 terabytes of storage space. It's going to be an enormous file. So once we've got that sorted, we can spit it out and then we can hand it over to the client or the online editor and they should be able to take it from there. So this has been a good overview of the process of delivering a project for cinema. We are nearly at the end now. It's been a long road, but keep at it. We've got one more module to go and then you're finally finished. So click on through to the next lecture once you're ready.